Hello everyone, I welcome you all in this course Introduction to Sequence Stratigraphy, and as we are discussing on the different types of systems tracked in last few classes, we will continue that discussion, and today and in successive classes we will discuss about another very important systems tract, that is the falling stage systems tract or FSST, which forms commonly during the forced regressive phase in the marine or marginal marine system. So, we will discuss about the different aspects which are related to forced regression in the marginal marine to marine system, and what are the depositional erosional manifestations, representations during this forced regressive phase at different depositional environments, and what are the final outcome in terms of the facies architecture or in terms of the overall stratal stacking pattern, overall distribution of the depositional systems. So, that will be our discussion in this class and also in successive classes. So, our topic is falling stage systems tract. This falling stage systems tract, this initially was identified as part of the low stand fan. It was proposed by Posamentier et al. In 1988, and at that time it was considered as part of the low stand system, considered as part of the low stand of the base level. However, later on during 1990s, it was separated as a distinct systems tract. There are several workers, they have used different terminologies from time to time. For example, that we are using the falling stage systems tract, which is the most common and the present one which everybody accepts. Also, people used to call this one as a forced regressive wedge, people used to call this as a falling sea level systems tract, and etc. So, these are some background of this particular systems tract. So, basically people used to put emphasis on this particular systems tract, or they tried to identify this systems tract as a separate systems tract, because this particular phase within the base level change is very distinct and it produces very characteristic depositional erosional features within the overall cyclic sedimentation pattern, within overall cyclic successions, and thus the identification or rather the study of this systems tract is very important, and people have tried to understand the different aspects of this systems tract from long back. If I want to understand what are the overall distribution of the different depositional systems where sediments are accumulating or sediments accumulate during the falling stage systems tract. So, just a very simple diagram that can help us to understand this. So, maybe we can think of something from the continental side to the shelf part, and then we are going down to the slope and the deep basinal part. This is ideally a profile of the marginal marine to marine system. Now, on this part, say this is the end of the transgression phase, that is the TST. So, this is the maximum regressive surface, and on that surface, as we have already discussed in the last class, there will be the HST part. The HST prism will form, the high stand prism will form, and then in rest of the portion we will get these condensed sections which will be going on like this. So, this is the end of the HST phase. So, this entire phase is the HST, and this we have discussed in our last class. Now, from here on starts the falling stage. So, we are looking at, if this is the base level curve, now we are standing at this particular point, and from here we are covering up this entire phase, which is the phase of base level fall. So, during this entire phase, what happens? We get different types of processes going on at different parts of this basin. So, for example, if I look at the marginal part where it is starting with the fluvial to deltaic system. So, in that particular area what we get is a consistently forming erosional surface. So, that erosional surface can continue up to this point, that is, this point is the self edge. The self edge. So, up to this self edge we can get a continuous erosion, and this surface that is forming over here is called as the subaerial unconformity. The subaerial unconformity is commonly associated with the formation of incision, river valley incision or bypass. So, at the end of the HST the water level was here. From there the water level is coming down to this particular level or maybe even below this. So, in response to this fall, what we get over here in this portion, we get offlapping delta system. So, offlapping delta system will be formed at the self edge. Commonly we call this one as the self edge delta. So, this self edge delta, which will be showing this kind of offlapping pattern with successive fall in the base level, successive fall in the sea level. And in association with this, what we also get in the deep marine part is the deposition of some high density debris flow deposits, high density sediment gravity flow deposits initially, which commonly is a mud flow deposit, which may be further followed by some high density turbidite deposits. So, high density turbidites, and this is debris flow deposit. So, during the falling stage systems tract, we will not get any deposition across this entire area starting from here, from the continental side up to the self edge, depending on how much is the fall. Say for example, the fall is somewhere up to this, then the subaerial erosion will be confined up to this only. So, considering that the base level is falling up to the self edge, then we can expect the subaerial erosion, subaerial unconformity to form up to this extent, up to the self edge. And at the self edge we get formation of this kind of deltaic system, offlapping delta lobes, which will be forming over there along the slope of the basin, and there we get a self edge delta forming during this falling stage systems tract. So, the proper preservation of the falling stage systems tract as a deposit, as systems tract are nothing but the depositional systems. So, that starts from here, from this point onward, because before that dominantly it is an unconformity. So, it starts from here and it is further represented in the deep basinal part, where it is represented initially by a debris flow deposit, which often is actually represented by mud flow, and followed by that some high density turbidites, which are dominantly sand dominated. So, this is the overall distribution pattern. So, what we expect over here, we are expecting a very complex pattern, a complex processes going on at different parts of the basin. And definitely all of this will not occur or form at the same time, because this fall is not going on rapidly from this level to this level. This takes place in subsequent phases. The base level will fall in subsequent phases, and when for each level of fall, for example, if I segregate this into individual time planes, then for each and every time plane we get a falling level, and for that particular level of fall we get a particular depositional condition. So, the final result may look something like this, where we can expect dominant deposition over here. We can get some remnant depositions in these areas as well, that we will discuss in detail in later slides. So, this is the overall distribution pattern in terms of the falling stage systems tract that we can expect ideally in a marginal marine to marine depositional condition in a common ideally sedimentary basin. So, the FSST, it is commonly bounded, as you can see from this diagram, that this is commonly bounded at the top by a composite surface, because at the top part, if I go back over here, So, over here the boundary is subaerial unconformity. In this part, these are the offlapping portions. So, they are the youngest part of the regressive surface of marine erosion. Successive regressive surface of marine erosions are forming, and these are the youngest part of that regressive surface of marine erosion, RSME surfaces. Whereas, in this part the surface is a correlative conformity surface, even maybe this one is a correlative conformity surface. So, if I want to mark the top surface, top bounding surface of this FSST, it is a composite surface starting with subaerial unconformity in one part of the basin, correlative conformity in some part of the basin, or in certain portions depending on the mode of preservation, we can get the youngest part of the RSME forming the upper boundary of the FSST. So, it is a composite surface. If I look at the basal part of the FSST, which is present over here, so in major part it is the unconformity again, where it is erosion or simple bypass. So, that is again the subaerial unconformity, that is the lowest boundary as well. And in some portions, for example, over here in these portions, maybe in this part, we can get the BSF or basal surface of forced regression as the first surface or as the bottom surface, bottom bounding surface. Whereas, for the next portions, for example, from here on, as we have discussed earlier also during our discussions on different types of surfaces. So, this portion may be represented by RSME surface. So, basically the bottom surface is commonly represented by where the FSST deposits are present, there it is represented by either BSFR or RSME. Where no depositions are available, there the bottom surface and top surface are merged, and there is a single surface, that is a subaerial unconformity. So, FSST is bounded at the top by a composite surface, whereas at the bottom part in some portion it is a BSFR, in some portion it is the RSME. Now, regarding this subaerial unconformity, already we have discussed about the subaerial unconformity as a surface, and there also we have discussed about the fluvial incision process. But now, as we are discussing about the depositional processes, or rather the overall sedimentological processes that will go on during the forced regressive phase. So, I think that we should have a little bit more detailed discussion on how this subaerial unconformity forms or how this fluvial incision occurs. So, the formation of the subaerial unconformity in the non-marine portion of the basin during this forced regressive phase, during this base level fall, it commonly involves combination of several processes. What are those processes? It includes fluvial incision, fluvial bypass, and when we have fluvial bypass in those areas, particularly in the interfluve areas, we get pedogenesis or some sort of deflation. So, when this fluvial incision is caused by the base level fall, it occurs only in the areas where base level is lowered, and that lowering should come below the major topographic break. So, that is very important. Until and unless the level of base level fall, the extent of base level fall is crossing or going beyond the major topographic break, we cannot expect fluvial incision. So, commonly what we expect, there should be at least some sort of depositional break, depositional topography and topographic change, and the base level will fall below that topographic change. Say for example, again we can go through a simple diagram to understand this. Say for example, we have an area where this is the high strength prism has formed. So, if I want to make a block diagram, so it will be like this is the high strength prism, and then it comes the self area and then the self break, it goes on like this. So, this is the self break area like this. So, this part is the high strength prism. Here we are getting a break in topography, break because of during high strength we got a deposition over here, not in this part, in the rest of the portion. So, this topographic break, if you have a river system coming over here, say it was present during the HST phase, forming a delta somewhere here, as we have discussed during our class on HST. Now, from here, this was the level of water, say level 1 at the end of the HST, and from there the water level is coming down to somewhere, say level 2, somewhere here. So, now the sea level is somewhere here. So, definitely there is a significant break in the topography, break in the base level, change in the base level. So, the river system has to come down to this level, and in order to come down to this level, this river will incise. So, the river valley will incise over here and will get a downcutted river valley. So, initially the river valley was something like this, now it will downcut and it will come down to this level. So, there will be vertical down cutting like this. And once the river has reached over here, from this point onward, there will be no further down cutting and the river will just flow like this, and this area is now the bypass zone, because this is almost a flat area where no further deposition is going on, and this is also exposed area because the base level is somewhere here. But since there is no topographic break, so no incision is going on. So, there is basically bypass is going on, and this river system will supply the sediments to form a delta over here. So, we will get a delta forming in this part. So, this kind of condition is commonly expected. So, when we get this kind of topographic break, we can understand, we can see that there will be a gradual down cutting. So, initially the river equilibrium profile was here, now we have a sudden topographic break. So, the river profile has to come down over here. So, this much will be the down cutting, this much will be the incision. Once the river has reached this level, the incision will stop, river will flow, it will carry the sediments, and that will distribute the sediments or dump the sediments over here, where it is getting the water body. Now, if we think of, say the water level has reached, say for example, this is the self edge. So, the water level has reached over here, maybe at the self edge, so level 3, or maybe even below that, level 4. So, the water level is somewhere here now, this is the water level. So, in this condition what will happen? Now, there is another topographic break, this is again a depositional break, again a topographic break. So, in this condition the river will try to come down over here, because now this area is exposed and the river will try to come down to this level. So, there will be again incision, just like the previous case, incision over here in this part, and a delta will form over here in this portion now, and the river will come down to this level. So, now in order to have a balance from this point, the elevation of this point and this point, which is a significant gap, there will be significant incision over this area as well. So, now what will happen? The river valley, initially it was showing a break like this. So, initially the river profile was like this, from there it changed at the very first instance over here up to this, then it was going down like this almost at the same level. Now, suddenly it is going down to this level. So, the river valley itself will try to adjust itself up to this point like this. So, now this area, which was earlier a bypass zone, will also face incision by the river because of this much of fall. Definitely these areas, the associated areas, there we will get dominantly the bypass, and these areas are the elevated areas. So, from those areas we can expect several tributaries to come into this or join this river, which will be also incising because they have to come down to that level. So, we can get multiple tributaries forming over here, which will be incising tributaries. So, fluvial incision, it will always start from the downstream end of the subaerially exposed steep topography, whether it is happening over here, whether it is happening over here, and from there it will propagate landward always, because the river profile will try to gradually adjust itself with respect to this sudden change in the topography. So, in contrast to the bypass or the aggregating systems, when this kind of incision is going on, these incised valleys, they will commonly show very characteristic V-shaped cross-sectional profiles. This is applicable to the main river system as well as all the associated tributaries which are also incising under this particular phase. So, whenever there is a down cutting, they will try to acquire a V-shaped cross section profile. Now, when this base level fall is occurring, the fluvial incision is commonly associated in those areas, or rather we can observe this fluvial incision in only those areas which are subaerially exposed. So, where we are getting a subaerially exposed seascape like landscape, seascape, and that seascape is steeper than the fluvial graded profile as we have seen in the diagram. So, whenever we are getting a steeper topographic change with respect to the graded profile, the fluvial graded profile will try to adjust and there we will get this incision. So, this fluvial incision will start from that particular point where you have the maximum gap, maximum difference in the topographic level. From there the incision will start and gradually it will move backward in order to adjust the entire fluvial graded profile, and in order to adjust that we commonly get successive migration of the fluvial nick points which will gradually migrate upstream, and when this is happening the erosional surface or rather the subaerial unconformity will also gradually spread towards the landward direction. This already we have discussed, this migration of the fluvial nick points, how it migrates toward the land and how this subaerial unconformity also spreads in both directions, that we have already discussed in our class on the subaerial unconformity. So, I will request you to just refer back to that particular class to get back to this. So, the high stand prisms that forms during the HST phase, particularly in the fluvial part or even particularly within the marginal marine to little bit of within the shallow marine part, they remain abundant when this particular area is getting subaerially exposed, and even that subaerially exposed condition can extend up to the continental shelf. So, those areas which are lying behind the forced regressive shoreline, they get subaerially exposed. So, it can be continental shelf part, it can be the shallow marine part, it can be the marginal marine part, and definitely the fluvial part. So, they provide classic examples of depositional features or scarps that are prone to fluvial incision during the base level fall. However, in certain cases very specific deviations are there where we have to be little bit careful, because sometimes in certain basins, particularly in the continental shelves, we can get some structural features, maybe some major faults which are present in the shelf area, and a movement along that fault may produce a fault scarp, and that fault scarp can result in a topographic break, a topographic difference. And when we get that kind of topographic difference, similar kind of fluvial incision, fluvial down cutting is expected. Say for example, if I just try to explain this with again a very simple diagram, exactly the same diagram. So, maybe this is the depositional part, maybe this is a part of the shelf where we have a fault system. So, with respect to this fault system, the shelf is going on like this. So, over here like this. So, this is the fault over here. Now, earlier the water level was here. Due to this fault activity, due to this subsidence, water level is coming down to this. So, if there was a river which is flowing like this, so it is suddenly facing this gap. exactly like the depositional gap, the HST prism that we have discussed in the previous diagram, exactly similar kind of gap, but now this is a fault scarp. This is not because of deposition, this is not because of HST or not because of falling stage, not because of forced regression, just because of some structuralism, some tectonic reason, and there also we can expect the fluvial system will come down over here, we will try to form a delta over here through incision, through down cutting. So, we can get a fluvial incision over here as well. So, in this kind of cases, which may be rare cases, but these are also possible, and we have to be careful when we interpret about the forced regressive condition, when we interpret about the falling stage system tracts, we have to remain careful about this kind of situations which may also occur, which may also happen and can result in similar kind of fluvial incisions. So, we have to be careful about this kind of scenario. Now, if I look into the unincised fluvial systems, is it possible? Yes, it is also possible. Already we have seen that, because unincised fluvial systems can also form at the same time when fluvial incision is going on. So, this may also form in the falling stage in the salomarine basins, where there is no such sharp change in the depositional profile, depositional topography, and it is a overall very gentle slope is continuing for long distances, for larger areas. In such areas, even during the fall, we do not expect much fluvial incision in respect to the falling condition. For example, in the gently sloping ramp margins, for example, such ramp margins can be found in intercratonic basins or in foreland basins, foreland systems, or in the continental shelf settings where the forced regressive shoreline does not fall below the elevation of the shelf edge. Just I will refer back to our first diagram that I have drawn today about the fluvial incision. So, there when the water level was within the shelf level, it was not beyond the shelf edge. So, there we are getting a delta and the fluvial system was going through some bypass, but not incision. Incision started in the shelf only when the water level came below the shelf edge. So, except that particular case, when the water level is above the shelf edge, it is lying somewhere within the shelf, we will not expect fluvial incision within the shelf system. So, what we get at that time? Unincised fluvial systems. So, that means the fluvial system is flowing, it is carrying the sediments, but they are not getting deposited as such. But if they are getting deposited, they will follow the normal fluvial system, because that area is now exposed, that area is not under sea cover now, and it is a completely fluvial system that will continue over there. So, the separation between incised and unincised falling stage fluvial systems is very important, because the depositional conditions, the depositional packages in these two fluvial systems will be completely different, and that difference in the sediment package is very much fundamental in terms of occurrences of petroleum, in terms of occurrences of hydrocarbons. And so, understanding this nature of the fluvial depositional system, fluvial system, whether it is a incised or unincised falling stage fluvial system, it is very important to understand to design the methodologies, to strategies for petroleum exploration, because the fill of the incised valleys and the unincised channels are completely different. When it is an incised valley system, it is suddenly cut, it is cutting across all the facies types which were occurring over there for a long time. But when it is an unincised, it is a continuous depositional condition which is also overlapping with the adjacent conditions. So, if I want to compare between these two types, incised valley fills or unincised fluvial systems or unincised channel fills. So, what we get over here in terms of stratigraphic architecture, they will be incised valley fills will be quite complex, which can vary from fluvial to estuarine to open marine. These different types of depositional systems may be involved over there, whereas in case of unincised fluvial system, it is a relatively simple one, because here we commonly get only the fluvial deposits, because it is a purely fluvial condition. It is an exposed now, it is not under sea cover, and not much of erosion is also going on over there. So, as the incision is going on in incised valleys, so it is more deeper with respect to the wider. So, commonly we get width is to thickness ratio that is relatively low, around 200:1, whereas in case of unincised river channels, there is incision is not there, down cutting is not there. So, the river valleys are quite wide, and we get width is to thickness ratio can reach up to 1000:1. The tributaries, if they are present in incised valleys, the tributaries also are incised in nature, whereas in case of unincised fluvial system, they are unincised in nature. Similarly, if I look into the overall potentiality in terms of gas or oil production, the incised valley fills, they are potentially very high in terms of gas or oil production, whereas in case of unincised fluvial systems, their potentiality is average, they are not excellent. So, this idea whether this is an incised valley system or unincised valley system, that can be done, that can be understood through a detailed imagery of the subsurface fluvial system, which can be done through 3D seismic or well log or core data. And from that we try to understand the overall stratigraphic makeup and the architecture of the fluvial systems. We try to understand this aspect ratio with respect to width versus thickness, the characteristics of the tributary systems, and etc. And when we try to understand all this, we can understand, we can get these distinct characteristics. So, incised valley fills commonly form stratigraphic anomalies, because they are cutting down across the sedimentary succession which has formed earlier. Now, they are just down cutting through them, which may be part of the HST, and that HST may be constituting part of the fluvial system, part of the estuarine system, or maybe part of the marginal marine to shallow marine system. So, if I look at the overall down cutting of the fluvial system and then it is getting filled up by fluvial sediments, that fluvial system will be completely distinct with respect to the adjacent facies types, adjacent depositional systems through which it is down cut. So, they are genetically unrelated to the adjacent facies. Whereas, if I look into the unincised channel fills, so they are producing normal channel systems where due to just exposed condition, as the sea level has retreated now, the shoreline has retreated down. So, these unincised channel fills, they will be associated with formation of normal fluvial system with overbanks, tributaries, and they will integrate within the overall paleogeography of the adjacent areas as well as the underlying depositional environments. So, there will be no sudden break or no sudden distinction in terms of facies distribution. So, that can help us in understanding or recognizing whether the valley fill is an incised valley fill or this is an unincised valley fill system. Okay, so overall this fluvial incision is one of the very important aspect associated with the forced regressive phase, and that is why I tried to spend little bit of time over here to explain this particular aspect, because this is very important in terms of formation of the unconformity, or whether a unconformity will form or not, that depends on in which part the incision is going on and which part incision is not going on. We are getting unincised river valley system. Apart from this fluvial system, apart from this incision process, we can also get FSST deposits as a true deposit, as offlapping shore face lobes on the continental shelf, We can get FSST deposit in the inner to outer self as major macroforms. We can also get FSST as a deposit in the self edge as a self edge delta, which downlaps on the continental slope, and also we can get evidence of FSST, record of FSST at the basin floor as part of the submarine fans, as we have discussed in the very beginning of this class, in the form of debris flow deposit or high density turbidites. So, definitely these deposits, they do not necessarily coexist. They can form at different time intervals, they can form at different areas from basin to basin. Their distribution pattern also may vary depending on the extent of the fall, depending on the nature of the depositional basin. The type of the falling stage facies that accumulate at any given time depends largely on the position of the base level relative to the self edge elevation, and it implicitly depends on the location of the shoreline relative to the self edge. So, we will continue this discussion in our next class, where we will try to understand this particular aspect, that when this base level is falling, apart from the river incision, what are the different depositional features in terms of distribution of the depositional environments in the shallow marine to self and deep marine part, and what are the responses at different phases of the base level fall of this force regressive phase. So, these are some of the references that you can follow for further reading. We will continue this discussion in our next class. Thank you, everybody.